Hey, thanks everybody. So as John said, I'm Tracy Bannon, and I'm a senior architect with Deloitte. I do a lot of focus on government right now. That's not always been the case. As part of that journey, I met Lori. We've been working together a couple of years now, so we had the luxury of getting to collaborate on this, and a couple of other projects that we're working on together, where we are going to talk about some of the things that we experienced firsthand. Have you guys all been enjoying the conference so far? I see it's people starting to, it might be just that we had lunch, kind of like everybody's getting kind of muted, kind of end of the week. So I think it's been a really good conference so far. A lot of words, a lot of buzzwords we've heard all week, right? We've heard cloud, DevOps. So I guess those are kind of some of the hype words from last year and the year before and the year before and the year before. Microservices, we're hearing less of that. That's kind of nice, kind of getting tired of the term microservices. However, containers, right, is the new hype word. It's unfortunate, but it is what it is. I'm a believer, a huge believer, that you can learn as much from a bad example as you can from a good example. So as we were thinking about how we could talk about this, we decided to not give you another best practices listing. We decided to come at it from the opposite and talk to you a little bit about things that we've been seeing that we don't really want to see. All right, agenda. We just talked that through. Okay. Public service announcement. Deloitte likes me to talk about this, but there's a reason that it matters. Big consultancy. So the reason that matters to you is that means that Lori and I have access to a really rich set of good practices and bad practices and examples. That's why that matters, guys. So get your phones ready. But before we do, show of hands, how many people are using containers right now? About half, maybe a little bit more. Okay. So here's what I want you to do. Grab your phone, and you are going to answer this question. We're going to make a word cloud together. So I want to know how you're using containers right now. And we'll see if we get any duplicates here. Development, okay. So if you're having trouble, you type the number first, so you'll be texting to 22333, and then you actually put in that code. See that code up at the top? There we go. There, we're starting to see some words up there. Thank you, guys. Thought you were going to leave me high and dry. Thought I was going to have Lori putting words up here. A lot of development. Oh, jump starts. Services, pipeline. Here we go. More services.
I like the maybe.
I like the maybe. Why do you use them? I don't know. Big stuff. There, we're growing. A lot of development. Less production. Notice that? Pipeline is there. Not a lot on the desktop. Okay. Cool. All right, we'll give you guys one more second. I see Ryan putting in like 6 of them. All right, guys. So, all right. I'm going to move us forward then. So thank you for indulging me. Because you guys, you're going to look at your phones anyway, so you might as well look at it for my purpose, right? So what are you going to learn today? Right, so we've been working with containers. We've been seeing containers. We've been understanding the good, the bad, and the ugly of containers. So just a couple of things that we want you to for you to understand and walk away with. So there's an ecosystem. The reason that we say it's the golden hammer is that I firmly believe that it's being used for everything. Anytime I talk to a developer about what, I would not say every developer, but most of the developers, we ask them what they're doing, somehow they figure out a way to say, well, and containers. I'm doing blah, 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 containers. Like, I don't know if they know what the word means, but I hear, and containers. So we're seeing that. So today what we're going to talk about just a little bit is what they can solve and what they cannot solve. We're going to give a little bit about some layering decisions, because it's really important. People ignore it entirely. A little bit about adoption. So I do want to talk about the human component of this, because that's another place where we tend to not always spend as much time. So Lori, the number one, the most prolific anti-pattern that we see right now is what? It's our VMs, getting into VMs.
Yes. Yes. Oh, is it? You can hear me now, right? Okay.
Yeah.
It's just another VM, right? That's what everybody, containers, they're just like VMs.
Or
Except they're not. Except they're faster. There you go. Yeah. Yeah. So containers is a substitute for VMs, which of course they're not. Just like, I don't know how many people heard Daniel's discussion yesterday. They are virtualizing the OS, not virtualizing the hardware. So lighter weight, special purpose versus VMs being heavier weight and general purpose. So we have a client that likes to use VMs, but they use them just like their hardware. Okay? They do not snap images after they install, except for their base OS. So they install their base OS, they snap that image, and that is their entire library. And now if you want to add any software, they go manually install it on every one of your VMs.
Exactly. And I know her client, it takes 6 to 8 months
to get a VM.
To get a VM.
That has everything you need in it.
Right? That doesn't give you everything you need.
Everything they'll give you before you have to do the rest of the work.
Exactly.
So again, heavy duty or general purpose versus the lightweight and special purpose. So using them as a VM, thinking of them as a VM will actually cause you to be less lightweight. You'll end up having some of these decreasing operating efficiencies because you'll start overloading your your container. And you'll also introduce some security vulnerabilities. Can we go to the next slide, please? Mm-hmm. So let's talk about what you need to do to make those containers work well for you. Let's not think of them as VMs, but think of them as that single binary, as part infrastructure as code, part of what it is what you're going to deploy. So start small. Only what you absolutely have to have. So we have the containers we're using as we build out are stripped down to the bare minimum part of the kernel, and that becomes our base image that we share to build everything else on. At that point, that's, again, full infrastructure as code. That's in our Docker file. So that's the one everybody starts from and adds to. They have to think about it if they want to add a utility. So you'll notice that layer of a CentOS utility up there. If they actually need a utility because they're launching something, like maybe they need to cron something in the midst of their program or something a little strange like that, they need to install that. They need to actually code that into their image. The one that actually comes to mind is we were building a container with an LDAP server in it. And one of the things we had to do was code into the infrastructure as code, the Docker file, the base user and the base password. And the one port, 389, open up 389. So we don't have 22 open. There are no ports open. So these are cybersecurity dreams. You have no port exposure unless you actually code it in, okay? Don't run the services. Don't run all your extra libraries. Do not put, if you don't have to, don't put the whole, don't put all of JBoss in there, okay? Don't put every Red Hat library you could think of in there. Please don't put WAS in there. Okay, so lightweight, not WAS. Okay, lightweight, deliberately define the layers. So standardize as much as possible on those. And let's go to. We'll get into the layers, defining the layers in a couple of slides,
a couple of minutes.
Because we'll get into a little more detail on those layers. Reusing them whenever possible. So do some reuse. Be careful about cut and paste errors, though. I see a lot of people doing some cut and paste when they're trying to reuse, and they end up getting all kinds of extra things they don't want, like some of those open ports that they never wanted in the first place. Yes?
Eliminate what you don't use. Use the host operating system to run apps.
Thank you. That's a very good point. So I hear these rumors that you can run Linux containers on Windows. Yeah, while it's technically possible, it's not necessarily the wisest thing to do. Because now you've added another layer you have to transition another layer, so now you're starting to impact your performance. So that's why we're talking about using the host operating system. Run Linux containers on Linux, run Windows containers on Windows.
What about for development?
So I actually agree with Daniel in his conversation about, he called it mechanical sympathy. If you don't use the same thing you're going to deploy to production, you will have unexpected consequences.
Yeah.
You will have things that don't work. So I would say, even in development, make it exactly the same as what you're
Parity
going to put
anywhere
in
that you
production.
can have parity.
So one of the biggest ways we've used it with our client, okay, so our client's not deployed, you already heard about our client and its VM story, right? We are using containers in our development because we reproduce down to the same exact versions of software that we're going to deploy on in a container. That allows us to do very fast cycles in our development, even though the client doesn't deploy it that way. So that gives us that mechanical sympathy with the deployment environments without having to live with their deployment environments.
Now, it's interesting. In that case, the servers themselves, those VMs, still have people touching them. So while you've got this beauty of using the images and having really tight control over them in development, actually the development environments are more tightly managed and maintained and controlled, right? We own those things than the production environments that our assets are being deployed to. So it's kind of an interesting dichotomy we get into. We're excited to move that from environment to environment, as they won't allow us yet to use containers in the upper environments for this particular client.
They're evolving, though.
They're evolving.
So this is a great evolutionary approach as well. You're evolving your architecture at your deployment level as well as at your build. Okay? All right. Tracy, what's our next wonderful anti-pattern?
Well, so all of these things that we're talking about, folks need to be educated about them. I want to draw your attention to a couple of words up here. So if you take a couple of snippets home, purpose, understanding. A word that Lori didn't use, but that always comes to mind for me, is intentionality. So you be very specific and deliberate on the things that you're putting into your container and not putting into a container. And I would say, and if you are using containers, because containers are not for everyone and they're not for everywhere, right?
I don't want my big ball of mud in a container.
And that gets into some of the problems that you talk about in lift and shift and people putting everything into there. It can be a transition where you may want to put a large monolith in the container, but then there has to be specificity on when you're going to get past that, right, to avoid.
And don't claim they're lightweight, please, when you do that.
At that point, no. At that point, no. So I'm going to talk a little bit, guys, about the next anti-pattern, and this is more of a human aspect of an anti-pattern. Just like one developer says, I'm going to go and do this, there are organizations who really are trying to adopt it because they want to adopt it. They haven't thought through the architectural trade-offs. They haven't
solve my problems, though.
Yeah, it's going to solve your problems.
all my
Well, we've
problems.
said that. Cloud is going to make you, 6 inches taller. DevOps is going to make me 20 pounds lighter, right? And going down this container is going to put money in my pocket. So yeah, it's a golden thing. It is the golden hammer. It will solve everything. So let's talk about what we're seeing. So what I'm seeing is that organizations are saying, let's go for it. Go for it. But they're not structured to handle it. So think about a waterfall organization. A waterfall organization is not built, and when I say waterfall, I don't just mean the methodology, I mean organizations that have developers that are separate from their architecture groups, that are separate from their operations group, that may even have a sub-team that are deployment only, which is separate from the database, which is separate from the monitoring. You've seen those organizations. Define a container that everybody agrees to, that could be moved through. They can't open it up and see it in their minds. They will not agree to it. So if your organization isn't built around this concept, it won't. So you're thinking about, your BFF mentality, right? Your business feature focused, right? That leads you to being more agile. Agile naturally kind of segues into DevOps, which takes us towards smaller distro packages, right? Your organization has to support those things. Does that make sense, guys? Okay. So another part of this, teams aren't empowered. What do I mean by that? Well, it's the same thing with the organizational piece. Got a lot of, I'm trying not to pace, I'm a pacer. Governance, heavy-handed governance. So if my container is dictated centrally and I have to go and get the container that is dictated centrally and I can't make a change to it, got another client where all of the containers are coming out of or sourcing out of a central Ivy Tower group. All right, so that doesn't help anybody to learn. They're just using what's there, right? So you want your teams to be empowered. And the last one is, it's kind of hard to use a container if you're not going to be able to use the automation to push things forward. And when we first have developers, we get a little hardcore with some of our newbies coming right out. And we have them pull stuff down. And we have them doing as much as they can with their own hands so that they learn how to do some of these things with their own hands. But I don't expect them to push something out across the pipeline, right? I don't expect them to, they need to know how an actual build works, how the images, how the binaries get created, how they get pushed into the repos. So those are some signs that your organization may not be ready, and signs that your people aren't ready. Well, they're making mistakes. They're doing things, patterns that you don't want out there. Overly complex containers, Lori talked about that, right? They may have a lack of a decent services model, right? Your decomposition of those services, they might have 15, 20. I've seen essentially more than one domain inside a container with microservices. I've seen 30 or 40. Why? Well, because we're working for that client. Well, come on, let's cut it down, break it apart. But they didn't know. They needed more education on it. Bloated containers, Lori talked about that. There's just too much in there. Do I need that? I don't know. Well, I might as well put it in there. No, it should be the opposite decision. Do I need that? I don't know. I'll leave it out. Right? A different way to approach it. Let's see. Simple facades with overly complex deployment patterns. There's two things that I want to call out here. One is just dependencies. Containers, Lori will talk about this in a little bit in the layering strategy. You don't want to have dependencies between containers, unnecessary dependencies between containers. Layering strategy is a little bit different than having processes that have interdependencies on one another. Don't want that. The other part of that is, should I say another example that ties into that is using APIs to front very complex systems. And while you do want to be able to expose a complex system with a simple API, you have to be very specific and deliberate about how you are going to make sure that you are not too tightly coupled to what's happening on the backside of that. Think about your scaling, right? If you're going for high availability, if you're going for your distributed, for your elasticity, depending on how you've architected and how you've bound yourself to what's there, you can have problems too. Again, folks just aren't going to know because, wow, I've got a container. I'm just going to put a whole bunch of stuff in this. Ain't this cool? And then you get a sticker and you put it on the front of your laptop because you got a Docker thing going on. And then just general sloppy design. Just generally sloppy design. So what are we going to do? Well, if you want to be a little bit more mature your organization, if you can, structure around BFF. Right? Go for the business feature focus, right? Organize around that to the extent that you can. And you can see just a quickie example on the side there. Let's not have people who are specialists in just one layer. Let's have them understand that what their federated team needs to deliver, right? Tracking all those things together, I need, if I'm going for Agile, to get small features that get pushed out via DevOps and small packages that I'm enabling via container, right? It all segues. It all makes sense together. People have to have an automation mindset and skill set. And this should be table stakes. I say table stakes because this is not something that you can do without anymore, right? So when you're interviewing folks, when you're thinking about the next actions that your organization is taking, you have to have somebody who's championing this every step of the way, and in each one of those pieces of the organization. Teams educated on container design patterns. I think that's kind of a given at this point. And I'm going to come back and touch about this. Just enough governance. So I said that governance is bad. Governance is not bad. The right size governance is a good thing. So when should you have governance in place? What are the things that you should govern? Anybody? Silence, and silence is okay.
I don't want to govern silence.
Okay. So you should have governance where there is large risk. That's what you should govern. Other than that, you don't need to govern it. So govern where there's risk. Right?
So like your ports being open.
Like your ports being open.
cybersecurity, that's
Exactly.
where the risk is coming.
Different types of, how your security scans are baked in, right? How getting, with your container design, getting cyber, if you have a separate cyber organization, bringing them to the table as people who are helping you to build those in the first place. And a focus on, instead of getting that architectural board and everything is approved by them and everything comes out of them, loosen up the reins. Have them dealing with risk issues, have them be very communicative, and have them pushing out guidance. So you get when I say centralized guidance, I mean that to be an ebb and a flow. As teams learn things, they make those available, maybe whether it's centralized as a wiki or in some other way, right? Have that centralized guidance, decentralized execution. Does that make sense? And that's all the human capital piece, but I end up having to I said this before, I get parachuted in when there are problems. And actually, I see more issues around this than I do necessarily with the technology. So Lori, one of the things we talked about earlier, and you and I were brainstorming about this, is the impact of the architect in all of this. This week, there's been a theme throughout the week of whether we call ourselves architects, whether we call ourselves engineers. We decided a day or two ago that we're going to just change it to rocketects. So you feel free to use that. I think I'm going to change my Twitter handle. But with that, there's somebody who has to be thinking about strategy. Strategy still matters. Having a vision for how things are going to be accomplished, and that the people who are helping with this guidance and pushing that guidance out kind of leads us into the next anti-pattern that we see, and it's lack of having any kind of layering strategy. Laura, you want to chat through?
Yeah. And I would actually even say that it's even more imperative with containers that you have a strategy and that you have an architect. Because now you're going to put them on tools and they're going to elastically scale, and it's going to cost you $500,000 when you get a DDoS attack if you don't plan ahead. Okay? So we don't want that. The gold goes away from the golden hammer at that point. So let's talk about it. We talk about instability from poor version management. If you were in Daniel Bryant's discussion, he also mentioned very semantic versioning. Very important, because it's very often that people will they'll program or set up their Docker files so that they just grab the latest version. I don't know if you guys have, and they're not only are they grabbing the latest version, they're grabbing it out of the public Docker hub. There was, I think it was 6 months ago, somebody injected some Trojan software into one of the base images in Docker Hub, and everybody pulled their latest version, and all of a sudden, it's in their production environment. Not a good thing. So again, layering strategy is important, versioning is part of it. Deployment complexity from multiple dependencies. So if every time I have to deploy one container, I have to deploy 5 containers because they interoperate and they only work together, now I've just introduced a complexity that I didn't have before, and I've got I've got my ordering problems and my build complexities. You think class path problems are an issue in one container? Try having class path problems in 5 containers at the same time. Not happening. Performance impacts, fine-grained containers. So if you do a container for every single little getter and setter, obviously that's going to be a problem too. Now you're hitting the wire for every single little teeny tiny attribute you need. Same thing as coarse-grained, fine-grained, as we learned.
I think that's part of the problem there started with the whole term microservice. So whoever came up with the term microservice, kick them in the shins, because how micro is micro, right? That sounds tacky, but folks are still having a difficult time understanding what's the right size, and the right size is not based on lines of code, right? It's based on your ability to manage it, maintain it, and the impact on performance.
Yep.
That's the right size for your container.
Yep, absolutely. And then the security exposure from the uncontrolled layers. We talked about an example from pulling things from Docker Hub. but also the configurations we talked about earlier of having all the ports open. So our same beloved client that uses VMs also leaves every port open in that VM. So they could be hardening their VMs, but they're not necessarily. So this will be ultimately a good option, and which is why their cybersecurity organization wants to go containers, because they see it as an advantage that way.
Which is usually the opposite. We almost
usually
always
the
see it the
opposite.
opposite way, that cyber says, hell no, because they believe that it's new, they don't understand it, and there's a learning part to it. As we're able to talk with them about DevOps, and I'm going to use the word DevSecOps, even though I think it's a goofy term, baking in security from the very beginning and having them have their eyes on, as they understand that, then they come on board.
Absolutely. So let's talk about a well-defined strategy. Very well-defined dependencies. So let's talk about our layers here. We've got a CentOS image that everyone builds off of. We call that a composition image. That image by itself does not get deployed. That is a standard image that's been tested, that you can run through your pipeline, you can do all of your security scans against. So everyone knows that the foundation they're going to build their specific containers off of is already ready to go. Okay, it's one of those approved ones. If I want to do Java, I've got a second composition one with my JDK. If I'm going to build Python code, I've got a separate one with Python in it. Okay, so I'm not going to put Python and my Python libraries and my JDK in the same container, because there's no reason to, unless if you really have a weird app like that uses both Python and Java at the same time. I'd really like to see it, but I don't think I'd rather deploy. I don't think I want to deploy it. So that's part of defining your dependencies very specifically. And keep the number of composition containers down to as small as possible. Let's avoid proliferation, which will also keep our complexity down. After you've got a very small set of standard composition images everybody can do, you've made very explicit decisions or intentional decisions on what those layers are. Then after that, the development teams build very special purpose for their applications. That allows, of course, also for the optimum maintainability. Because if you think about it, if I want to upgrade when I'm using containers, now I want to upgrade my CentOS image. I have to go back and recompose all of my containers with a new version of CentOS, right? So it's not a lot of work. It's usually one line in my Docker file to change the version out. But it does need to go through the entire pipeline again, because it's got to go through all of the testing and make sure that something didn't jiggle in the base there.
So automation helps.
Automation's imperative.
But, right, it's an imperative. Automated testing is imperative, but at the same time, and a change is always an inflection point where issues happen, right?
Absolutely. And then we mentioned securing and standardizing those layers. Put them in a repository. Have a repository that everybody can share. Don't normally pull everything from the public repository all the time. Again, you don't control the public repository, and you will introduce problems. So it becomes a very thoughtful approach to versioning your dependencies, just like you already version your libraries. Okay?
Now, one thing I would add on to what Lori's saying is that layering can also be a dangerous thing. And the reason that we say that is that just like having no knowledge is a bad thing, a tiny bit of knowledge is also a dangerous thing. So we've also seen folks who, they get really inventive with how many layers that they believe that they're going to put together, and they try to get it down too thin, too small. And so now you've got 2, 3, 4 things as opposed to having 1 or 2, right? So why would you want to inherit 4 times if I don't need to? So there are times where you think about maybe I should have the utility, right? As opposed to having a separate layer for the utility if it is going to impact my performance, if it's going to impact. So again, intentionality of the decisions.
And that's a good point, too, to go back to your CentOS image. If you're going to do a lot of if you have a standard monitoring tool set that you have in operations, it's probably best to put that standard monitoring tool set in your base image. Okay, so that everything has that monitoring tool set and it deploys with every container. But it's not a layer, it's part of the base. Okay. So you don't end up with constant layering and constant refresh.
But that's a decision. I can
It's a
see the
decision to
opposite,
make.
that, hey, we are going to sunset this in 8 months. So do we put it here, or
Make the
do we put it in the
opposite
layer,
decision.
right? So then there's a decision that has to be made about it, so.
Yep, absolutely. So your inventory of required assets, your base images, your composition layer, which are usually your operating system level, your composition layer, which are the base tools that you're going to build on top of, and then your final containers, which are your special purpose application-based ones. SonarQube, for example, we've got SonarQube running in a container, and it comes up in that. Question for everybody. Do I put Oracle in a container? We had about half the people said they use containers. No, you probably don't put Oracle in a container. Why would you not put Oracle, besides the fact it's not lightweight, why would you not put Oracle in a container? There may be a licensing issue.
Oh, there would definitely
always
be a
are
licensing issue.
issues with Oracle, right? Okay. We love Oracle, but
I
That's such a
didn't say that.
Put it in the container, then you have to run it.
But that was good. That was very good.
how about the fact that containers are very ephemeral? They come up and down all the time. Is your database persistence supposed to be ephemeral? No, that's the purpose of the word persistence, right? Okay, so it's perfect for testing.
testing.
That's a
Bang,
very
yes.
good example.
I don't
So
want
you might
production.
put it in there only for testing, but you wouldn't want to be taking that to production. So that's using the sidecar pattern. So anything that you're going to use that's only for testing, you're not going to take to production, you have basically a sidecar container set that goes along to a certain point with your main container that goes all the way to production. Absolutely. Excellent. Okay, setting up guidelines. No, you cannot go and change my base images and open up and change the way it's configured. If you need a new port open, then you grab the base image and you have your own specific, you edit the Docker file. It's no longer the base Docker file, it's your specific Docker file, okay? That's how you add your ports. You don't go back and check it back in as the base image, so now everybody inherits 15 ports. We already talked about Java-based versus Python-based versus COBOL or whatever you want to worry about. And then just explicitly defining your dependencies. For example, we talked about SonarQube. SonarQube runs with a database, right? So understanding what the dependencies are of your containers will be important because that will go into your configuration as well. So for our LDAP server, for example, it's got to have a store somewhere. We didn't put the store inside of the container, but we did need to put the configuration inside that container so that it could connect. Now, relatively speaking, there's also the capability of using configuration servers, okay? So for all of our microservices, where we have varying credentials and things like that for them to connect in different environments, we actually bring up a configuration server that they communicate with to get the information they need to connect within an environment.
Right.
Now you're no longer injecting different information in that container as you go along, or you're not holding all of the credentials for all of the environments in your single container. It's much more dynamic and actually more secure that way. So that's an example. Optimal maintainability, if you have the right level of granularity. So we all know if we have to put the same code in 5 different places that it's probably not very maintainable, so same principle with containers. And we've talked a lot about security, so I think I'll leave it there. Manage your layers, control the ports and things like that. Now all of this, putting it in a build pipeline, now you can start using things like scans and I think Claire. Anybody have experience with Claire? No? So Claire is a scanning tool. The OWASP security tools. AppScan, I'm sure people have heard of AppScan. You've got Kubernetes has some different workbenches and things like that. All of those can be hooked up into your pipeline, your CI/CD type pipeline, to be doing those extra security checks and quality checks along the way. So that's in particular important. But there's 3. Do we have any more?
Any more patterns?
Anti-patterns?
Anti-patterns? But wait, there's more. No, actually, we had 12, and then we went to 6, and then we went back up to 8, and then we finally decided that 3 was enough, but that we would summarize, because this whole idea of a golden hammer in and of itself is an anti-pattern, right? So here's your in conclusion, guys. So containers are not a ubiquitous solution, and I have to say that for 4 years I've been looking for a way to use the term ubiquitous on a slide. So thank you. And so the next challenge, should you ever come to another presentation that I am a part of, look for the word archipelago. So, all right, so this is really summarizing what we've talked about already. If you don't do it right, what's going to happen, right? The same things that happen when we don't do standard architecture that's not using containers, right? You're going to use too many resources. You're going to have a lot more cost around debugging. It's not going to be maintainable. It's going to be more complex than it needs to be, right? That's not specific to containers, but it applies to using containers, right? So if I were going to say, when should I decide to use containers? Well, this is kind of just a baby checklist, and it doesn't have all of the trade-offs listed, but some things that should make you think it might be a good fit. So it might be a good fit if you're starting some new development, and you think about the architecture of it, and it fits. That might be a good place for it. High elasticity, that's probably a good time to check and see if it would work for you. You need feature sets, right? If we're going to be BFFs, right? And I need to roll those things out quickly. Might be a good fit. If my teams, my organization support it, I would be thinking about it, loosely coupled APIs. And when we talk about having well-defined seams, right, getting rid of those extra dependencies, it might be a good fit. So guys, that's all we got for you. I think we have about 7 or 8 minutes left. If folks have questions, or if you want to share some of your experiences, love to hear what you're running into.
So you mentioned earlier we're using containers for self-driving cars, and which has actually been fairly successful given some inherently containers running in the cars work. Because a headlight fails on the whole car comes to the street you multiply. So, but when it comes to development, every developer can't have a car. So we have virtual reality environments that are installed on each one of their desktops, but there's not parity there. It's Windows on their desktops and Linux in the cars. Do you think that's fair to say we can't have parity there, or do you think we should?
Well, I think if you evaluate what you're talking about, you have a constraint, right? And I think it was a conversation earlier today that talked about knowing the constraints and being aware of the constraints. You don't really have a choice to give everybody an actual piece of hardware, so you're going to have to deal with the emulation. But what's going to happen? You are going to need to be exceptionally smart about the impact of the emulation. That's what's going to have to be, because you can't give people if you can't give them parity, you better damn well know what the lack of parity is going to introduce or inject. So
And how to mitigate that risk.
Right, how to mitigate it.
So one way to mitigate it, for example, would be to use a VirtualBox, right? On their Windows, that's got Linux natively on their Windows system. That becomes a little more complicated, but it's possible.
Right.
Another different way to mitigate is to have a test bed and a phase in which you're testing fully natively before you go very far past development. So development, integration, test environment. So it's just, or a place that they can all share. And once they're done, the pipeline will push it to that place to test when they're still in development mode.
Yeah. So making availability of the hardware in a dev environment, but a shared way that you can have that availability.
Great, thank you.
And those are just 2 ideas, I'm sure you can
No, that's good.
more.
It doesn't matter.
Other questions?
Or examples, where else, and somebody, I know we put it up there in a text message.
I think
Anybody
the
else?
self-driving car example sounds really fun.
So I kind of have a scenario that we've been kind of chewing on for a bit. We're not sure if this is a good practice or not. We have, let's say there's a large number of services that we want to all use the same base image. Like it's something we own, the base image is in our private Docker repo. We have to update it. We have to say, the base image, and every repo has to get updated to use any base image. One idea that's been floated around is why don't we just default using the latest for those individual repos, and then we would just update the base image once and just recut releases for everything. Would that be an example of using the latest correctly, or, well, my gut is it seems like a bad idea, but we tend to be a little split on that idea.
Yeah.
We own the base image, like it isn't like something
I
like,
actually like the distributed repo idea because we have a situation where there's a centralized repo and we have a distributed repo. We're able to control what we pull into that, so we know we can do latest off of that because it's very well controlled.
okay.
This one is not.
Whereas the central one refreshes without our control.
Ah, I see. Okay.
So
That makes
it's
sense.
possible, and different projects have different release cycles, or different services may have different release cycles, that if you do use a distributed repository, you could do that.
Distributed with a instance per project?
Per project.
Project or
Yeah.
program.
One where you
How big
can
your
control-
portfolio is.
Yeah, one where you can control and one where the latest golden copy is.
It assumes your team is going to be able and mature enough to be able to handle that. So part of it is going to be, I'm getting down to the human capital
Yeah,
side of
that's-
it.
that's
It's
always
going to
my
depend
concern.
on their ability to manage and consume that.
And in your quote process, right? So one of the things that we've tried to introduce as a discipline within our project is that every time we start a new release cycle, we go confirm all of the versions. So we have an N+1, and we can't be more than N+1 out of sync with latest versions. So we just build that into the beginning of our process, and we enforce it with, architectural reviews and things like that.
Makes sense, thanks. Time for one more question?
Or a joke. Anybody?
Demos?
Well, thank you.